Hello everyone, this is Chem Bonding tutorial question number 10. It's on solubility. Solubility in water, solubility of a substance in an organic solvent. So these are what we're going to consider. Okay, the general rule of thumb is that light dissolve light. What does it mean? It means that substances, for example molecular, that has ID between its molecule, it will dissolve in a non-polar solvent which has ID interaction. Or polar solvent which has PD will dissolve polar molecules. So that is the general rule of thumb, okay, for solubility. Okay, so we look at 10A. Let's consider the three substances. The first one is methanol. Okay, what is the predominant type of forces in methanol? Remember, it has a H that can form hydrogen bond. Okay, so we will consider it as hydrogen bonding. Can it dissolve in water? Yes. Remember in question number 8, anything that can form hydrogen bond with water are able to dissolve in water. Okay, so this one is hydrogen bonding. So that's why it can dissolve in water. How about rubidium chloride? Rubidium chloride is a ionic structure. Can it dissolve in water? The answer is yes, because as you have learned in your lecture, ionic compounds can form ion-dipole interaction. So it can dissolve in water. How about iodine? Iodine, it says here, insoluble in water, because iodine, the type of forces between the I2 molecule is predominantly ID. So ID is not able to form hydrogen bonding in water. So therefore, iodine is insoluble in water. Okay, so this is the big picture for part A. Okay, so this is how I will write. Okay, similar to how you will describe melting boiling, we will first talk about the type of structure. Okay, methanol is simple molecular. It can form hydrogen bond with water, therefore it's soluble. Okay, for rubidium chloride, it's giant ionic lattice structure. It forms ion-dipole interaction, so that's the key word. Okay, then we will describe this interaction. This interaction stable enough because it gives out energy, and the energy given out is used to break up the ionic lattice structure, and that causes the whole structure, the solid, to disintegrate into Rb plus and Cl minus ions. Okay, perhaps just to draw out the structure. Okay, Rb plus form ion-dipole interaction with water molecule. Remember that this is a delta minus, so that's why we call this an ion-dipole interaction. Ion-dipole interaction. So if you are asked to draw, remember, like hydrogen bonding, I draw at least two structures, either the Rb plus or I draw the Cl minus. Cl minus will form interaction with the H of water. This is delta plus. So as you can see, this is my ion, this is my dipole, ion-dipole interaction, and I need to label it. This is called ion-dipole interaction. Okay, and then the last one, iodine. Iodine cannot dissolve in water because the weaker ID is not compatible. The hydrogen bonding between water molecule is not compatible, okay, with the weak ID. So as you can see here, since the two types of forces between water molecule and iodine molecule are different, that's why they are not compatible, and hence iodine cannot dissolve in water. And there are many other molecular non-polar compounds that are not able to dissolve in water. For example, we can think of O2, F2, Cl2. These are non-polar substances, hence they are not able to dissolve in water. Alright, part B. Part B, hexane is not miscible in water, that means it cannot dissolve in water. Okay, but is soluble in a solvent called tetrachloromethane, CCl4. Okay, let's consider the type of forces of interaction. Water you're familiar with, so we will not talk about water. Anything that dissolves in water needs to form hydrogen bond or ion dipole interaction. How about hexane? What type of molecule? Is it a polar or non-polar? Okay, remember in the lecture we mentioned that C and H have very similar electronegativity, and hence any hydrocarbon are considered non-polar. So if it's non-polar, what is the predominant type of interaction? Okay, it's ID-ID. So ID-ID, back to part A, are not compatible with the strong hydrogen bonding in water. Therefore, it's not able to dissolve in water. Okay? So that part we have taken care of. So it's not able to dissolve in water. But how about the organic solvent in CCl4? It's soluble. Why? Okay, what is the predominant type of forces between the molecules in CCl4? Okay, we know that CCl4 is a non-polar. It's a non-polar solvent, organic solvent, which is ID-ID, right? So the two type of forces are compatible. So this is how we will write. The weak ID-ID forces between the C6H14 is similar in strength or compatible, okay, to the weak ID-ID between the CCl4 molecules, and hence the hexane is able to dissolve in CCl4 organic solvent. And this is the principle for some of the organic solvents like kerosene, thinner, turpentine. They are used to clean off paint marks, clean off markers, mark on the wall, okay, because they can dissolve non-polar molecules.